In this video, you will learn about the multiplier effect and how to use a multiplier to calculate the final change in real GDP given an initial injection. In economics, the multiplier effect means that an initial increase or decrease in one of the components of aggregate demand will result in a larger overall increase or decrease in real GDP. In this image, we see the basic logic of the multiplier as one person's spending becomes another person's income. The plumber at the top of the page is paid $6 for this work. They take this money, save some, and spend the rest at a barber shop. The barber earns income from the plumber, saves some, and spends the rest at the mechanic getting his car fixed. The mechanic earns income from the barber, and the process continues on throughout the economy. We use the multiplier to trace the final impact of an injection on the real GDP for an economy. This is a vital concept to understand throughout your study of economics. The effectiveness of fiscal and monetary policy really hinges on a strong grasp on an economy's multiplier. This is true for both contractionary and expansionary policies. Spend time building your confidence with this concept, as it will strengthen your analysis and evaluation of the impact of injections and withdrawals on an economy. Now let's look at how we calculate the multiplier in open and closed economies and consider 2, 3, and 4 sector economies. In 2, 3, and 4 sector economies, the formula for the multiplier can always be expressed like this. It is equal to 1 divided by 1 minus the marginal propensity to consume, or MPC. The higher the MPC, the higher the multiplier value. We'll look at some calculations later to see how this works exactly. But the higher the MPC value, the smaller the denominator gets. When we divide 1 by increasingly smaller numbers, the result will be a larger multiplier value. Now remember, in the 4-sector economy, there are 3 withdrawals from the circular flow of income. First is taxation, second is savings, and third are imports. These each have an associated marginal propensity or rate associated with them, but together they form our overall marginal propensity to withdraw, or MPW. In the 4-sector economy, we can calculate the multiplier as either 1 divided by 1 minus the MPC, or this formula, where the multiplier is equal to 1 divided by the marginal propensity to withdraw, or MPW. However, in the 3-sector economy, the withdrawals are only savings and taxation. So in the 3-sector economy, we would calculate the multiplier by dividing 1 by the sum of the marginal propensity to save and the marginal rate of taxation. Similarly, for the 2-sector economy, where savings is the only leakage, the multiplier formula can also be written as 1 divided by the MPS. In the following worked example, we will see how the multiplier will affect a government's decision to close an output gap. The example is with respect to a 4-sector open economy. Let's use what we know to try and figure out the following problem. Suppose a government is facing an economy with an output gap of $500 billion. If you're not sure how I came up with the $500 billion figure, it is quite straightforward. The $500 billion gap has been identified by subtracting the current level of real GDP, or $2,400 billion, from the level of real GDP at full employment, which is $2,900 billion. In short, we could say the economy is currently producing $2.4 trillion worth of goods and services, but has the potential to produce up to $2.9 trillion worth of goods and services given their current resources. So the end result is a $500 billion gap. The government would like to close this output gap of $500 billion, but will spend only $100 billion to do so. If the MPC equals 0.8, then the multiplier is equal to 5 and the government is likely to be successful. Let's see exactly why, step by step. If the MPC is equal to 0.8, then the multiplier is equal to 1 divided by 1 minus 0.8. This is the same as 1 divided by 0.2, and this equals 5. So our multiplier is 5 and our increase in government spending is equal to $100 billion. So we multiply the $100 billion by 5 and this results in an overall increase of real GDP of $500 billion. So this $500 billion increase consists of the initial injection of $100 billion and the resulting $400 billion increase in spending as a consequence of the initial $100 billion injection. The final level of real GDP will likely match the $2.9 trillion level of output and the economy reaches full employment. The multiplier may be a bit tricky, so I'm going to include 2 practice problems to help. Problem 1. Suppose there is an open economy that is facing a deflationary output gap of $200 billion. The MPS is 0.2, the MRT is 0.1, and MPM is 0.1. Calculate the value of the multiplier. Determine whether an increase in government spending of $70 billion will be sufficient to close the output gap. Determine whether an increase in government spending of $100 billion will be sufficient to close the output gap. Pause the video here and try the calculation yourself. When you're done, continue with the video and I'll review the answers. The multiplier is equal to 1 divided by the MPW. The MPW is equal to the MPS and plus MRT plus MPM. Thus, the marginal propensity to withdraw is equal to 0.2 plus 0.1 plus 0.1, or it's equal to 0.4. The multiplier is equal to 1 divided by 0.4, which equals 2.5. If the government increases spending by $70 billion to close a $200 billion output gap, it will not be sufficient. This is because $70 billion times 2.5 equals $175 billion, which falls $25 billion short of the target. If the government increases spending by $100 billion to close a $200 billion output gap, it will be excessive. This is because $100 billion times 2.5 equals $250 billion, which exceeds the amount needed to close the output gap by $50 billion. In actuality, to close this output gap, the government should spend $80 billion. Problem 2. In a closed economy with no government, an increase in investment of $300 billion results in an increase in consumption of $1,200 billion. What is the value of the marginal propensity to consume? Once again, pause the video here and try the calculation yourself. When you're done, continue with the video and I'll review the answer. If the economy is closed and has no government, households can only consume or save, which means we will only have an MPC and MPS. If an increase in investment of $300 billion results in an increase in consumption of $1,200 billion, then the overall increase is $1,500 billion. Given an overall increase of $1,500 billion, we can work backwards to our multiplier. So M is equal to $1,500 billion divided by $300 billion, which is equal to 5. If the multiplier is 5, and we know the multiplier is equal to 1 divided by MPS, then 5 equals 1 divided by MPS. So it should follow that our MPS is equal to 0.2, and then the MPC must be equal to 0.8. Be sure to review this video carefully and make sure you have a confident understanding of the multiplier and the multiplier effect. If you have any questions about what's been covered, leave a comment or question below and let's try and answer it together. That's us done for now, and I will see you in the next one.